Welcome back, guys. So I have got another amazing question from RMO 2013, which is asking us to find the value of 3 primes PQR for which these two expressions are satisfied. Okay, so when you look at these two expressions, what's the very first thing that comes to your mind? Looking at this expression, what's the very first thing that comes to your mind? I see a 2 here. What does this imply? This implies that this is even because it has a factor of 2 in it, which implies that this r square plus 1 is even as well. Okay, if this is even, we can say that r square plus 1 is even and 1 is odd, therefore r square must be odd as well, since odd plus odd is even. If r square is odd, we know that the base is going to be odd as well. And r is a prime number. So we can say that r is greater than or equal to 3. Odd prime numbers. Okay, we have deduced our first piece of information. Let's use it in our other expression. What's the other expression? PQ is equal to r plus 1. So we know that r is odd. And we know that 1 is odd as well, okay? And we know that odd plus odd is even. Therefore, r plus 1 is even, which means PQ is even as well. Product of two primes is even, and there is only one even prime, which is 2. Therefore, either P is 2 or Q is 2, okay? For P, the product to be even, okay? So, we can assume that by V log, without loss of generality, we can assume that P is equal to 2. You can do Q as well because both are symmetrical, it doesn't matter. Okay, P is equal to 2. Let's plug back into our original expression to see where what values we can get out. Okay, 2 square plus Q square is equal to R square plus 1. This is our first expression, and let's plug into our second expression, which is PQ is equal to r plus 1. Since p is equal to 2, I can write it as 2q r plus 1. Okay, let me bring it over here. Okay, so this will be 8 plus 2q square. You can do this by your method as well, okay, this manipulation thing. So I get r square as 7 plus 2q square. I have got the value of r square here. I just need the value of r square on the other side. This if I square on the both side, I'll get 4q square r square plus 1 plus 2r, right? Bring everything on other sides and you will get 4q square minus 2r minus 1 is equal to r square. Since I have got the value of r square on the both side, we can equate both equation and I'll get 7 plus 2q square is equal to 4q square minus 2r minus 1. Okay, so separate the constant and I'll get 2q square minus 2r, right? Now I can divide the whole equation by 2 to simplify for myself. Okay, this will give me q. Now I can get the value of q square over here, and therefore the value of q square is 4 plus r. Okay, so my goal is ultimately to make a single variable equation. Okay, so if I plug this back over here, okay, I'll get a single expression. So let me plug it over here. Okay, so we have 8 plus 2q square is equal to r square plus 1, and we just found out the value of q square. Let's plug in. Okay, so 8 plus 2, and then this will be 4 plus r r square plus 1. Okay, from here we'll get 8 plus 8 plus 2r plus r square is equal to r square plus 1. So bring everything on other side to solve the quadratic and you will get minus 15. Now factorize this quadratic, pretty easy. I'll get 5r plus 3r minus 15 is equal to 0. Take r common, r minus 5 plus 3r minus 5 is equal to 0. Okay, from here I can get the true value of r. Okay, remember that r is a prime, so I get r minus 3. Is minus 3 a prime? No, therefore reject this value. The other value that I get is r is equal to 5. Is r a prime? Yes, absolutely. And we know that q square is equal to 4 plus r, and if we plug in the value of r, we'll get q square as 9. From here we can get the value of q as well, which will be 3. Q is equal to 3, r is equal to 5, and we know that p is equal to 2. Therefore the first triplet that satisfies the equation is 2, 3, 5. Since I told you that p, q are symmetrical, okay, therefore the solution 3, 2, 5 would work as well. These two are only valid solution for which these two expressions are satisfied. I hope you liked the explanation. Don't forget to like, subscribe. Thank you so much.